All right, class. So today we're going to learn factoring difference of two squares and factoring perfect square trinomials. But before we start, let's go back and recall some information to help us with this class. So let's go back and talk about perfect squares. What are perfect squares? Well, remember, perfect squares are when you multiply two numbers and the product is a perfect square. So for instance, right, 4 is a perfect square because it is the product of 2 times 2. 9 is a product square because it's a product of 3 times 3. 1 is a perfect square because it's a product of 1 times 1. Also, is x squared a perfect square? Yes, it is, because it's the product of x times x. All right. And so the square root of 4 is 2. The square root of 9 is 3. And the square root of x squared is x. All right. So just want to make sure you guys go back and recall that. And so last week we learned how to factor a trinomial, a polynomial using the X box method. And so let's go and look at that. So last week we learned if you were given a polynomial such as 4x plus 4, and you were asked to factor a polynomial, you think about using the X box method. Remember that? And so you draw a 2x2 box. The first term gets the first term, last box gets the last term. And to find these two boxes, you jump over here. And this is 8 times C, which is 4, and this is 4, this is B, and you find these two numbers. I won't solve this. So that's how you would factor the polynomial using the X box method. We also learned what if you're given a polynomial but it's only 2 terms. So let's say 4x squared and 16x plus 16x. All right. Now, in a case like this, you wouldn't use the X box method. You would find the GCF. And remember, the GCF is you look at the coefficient first, 4 and 16. You find the highest common factor, which is 4. And then for x squared and x, the GCF is the x with the lowest exponent, which is just x. So that's your GCF. And then you just multiply each term, 4x squared by 4x and 16x by 4x. You remember how we did that, right? So that was last week. Now, today's class, we're going to look at factoring the difference of two squares. And difference is just the minus. So we have two squares with a minus sign between them. And the formula is a squared minus b squared. And that's just a minus b times a plus b. Yeah, and so when we do an example, you see how it makes sense when we do an example. All right, so let's look at an example first. Before I go into this right here, let's look at an example. Okay, here we go. So let's look at x squared minus 16. Okay, it's a polynomial, but it's a binomial, which is 2 terms. So if you look at this this box right here, it asks it is a binomial? Yes. That's the first thing you want to look at. It is a binomial. Are both terms a perfect square? Well, the first term is a perfect square because it's x times x. And 16 is a perfect square. So yes, both terms are perfect square. And then is there a minus sign? Is there a minus sign between the terms? Yes, there's a minus sign between terms right here. So all 3 checks are yes. When that is the case, this is how you find the factors. You take the square root of the first term, the square root of the second term. The square root of x squared is just x. The square root of 16 is 4. All right, so this is your A and that's your B. And according to the formula, right? All right, you're going to have 2 parentheses now. Both are going to have x and 4. You put an x and a 4 here, an x and a 4 here. Just like the formula, you have A and B, A and B. And then one of the parentheses gets a minus sign, and the other one, this is a plus right here, and the other one gets a plus sign. And those are the factors. If you use the box method to multiply these two terms, you get x squared minus 16. Right? So that's how we factor a polynomial when it's a binomial. But you got to go through the checks. You got to make sure that both terms are perfect square. All right. You got to make sure it's a binomial and then it's a minus sign. All right. So let's look at another example. Let's see. Now, this example isn't on the sheet. This one is not on the sheet. All right. So let's try this one. It's not on the sheet. So let's look at x squared minus 25. Okay. So let's go to the checks now. Is that binomial? Yes. Are both terms perfect square? Well, x squared is a perfect square, 25 is a perfect square, so yes. And then the last one, is there a minus sign between them? Yes, all three. So in a case like this now, you take the square root of the first term, square root of the second term. This gives me x, this gives me 5. I'm going to have two sets of parentheses. Right? They both get x and 5, but one gets a minus sign, the other one gets a plus sign. And that's it. So remember, you must have a minus sign. Some students, they make this mistake right here. This is a common mistake for kids. I'm going to use the same polynomial here, binomial, but I'm going to put a plus sign here. A lot of kids, they just forget the plus sign, that it should be a minus sign, right? And so they go like, well, it's x minus 5 and x plus 5. This is incorrect, because this is a plus sign. If it's a plus sign, you're not going to have any real solutions on it. So this is, got to make sure this is wrong. All right, this is wrong. All right, guys. Okay. Let's go back to the handout and see. Now, determine. Here, ask you to determine if the following are difference of perfect squares. Well, it's a binomial, yes. Are the terms perfect square? Yes, this is a perfect square because 4 and x squared are perfect square. 25 is a perfect square. But is there a minus sign in between them? No. So this is not a perfect square. No. So we say there's no real solution. All right. So the answer will be no real solution. All right. Now, what about the other one? Well, this is a binomial. It's two terms, yes. The first term is a perfect square. Second term is a perfect square. Good. And there's a minus sign in between them. So yes, this is a difference of two squares, and so we can solve that, and we can do that. All right, 9x squared minus 16 squared minus 16. Sorry, take the square root of both terms. Square root of 9 is 3. The square root of x squared is x, and so the square root of 16 is 4. So I'm going to have two parentheses now, two sets of parentheses. I'm going to have 3x and 4, 3x and 4, and then I put one gets a minus sign and one gets a plus sign. Okay. All right. Is this what about 14? Is that a direct difference of two perfect square? Well, this is a perfect square, but 14 is not a perfect square. So no, this is not a difference of perfect square. Here it kind of explains how to solve it. This is what we did a while ago, right? Check for do your checks. Is this a difference of perfect square? Both terms perfect square. I'm sorry. This is a binomial. I'm tired already. Is this a binomial? Check for it's the binomial by, oops, come on, binomial, right? You check out both terms perfect square, and is there minus sign? If those are correct, then you take the square root of the first term, take the square root of the first term, and then take the square root of the second term to find A and to find B, and you plug into the formula, just like we did before. One second, guys. You got someone at the door. All right, sorry about that, guys. Okay, and so then you plug in the formula and check your answers by doing the FOIL method. FOIL method. Okay, let's see. What's the next one? Here's some more examples. Look at number 16. Again, it's a binomial because that's two terms. Both terms are perfect square. 16x squared is a perfect square because 16 is a perfect square. X squared is a perfect square. 49y squared is a perfect square because 49 is a perfect square and also y squared. And so now we're going to take the square root and there's a minus sign in between. So I'm going to take the square root of this, the square root of that. Square root of 16x squared is 4x. The square root of 49y squared is 7y. So I'm going to have my two parentheses now, 4x and 7y in both parentheses. And then, oops, and 7y in both parentheses. One gets the minus sign, one gets plus sign. Look at C. Okay, a C. Look at C now. It's a binomial. It's two terms. Okay. The first term is a perfect square because k to the fourth is just k squared times k squared. So times k squared. So this is a perfect square. Also, 81 is a perfect square and it's a minus sign. So if I take the square root of k to the fourth, square root of 81, square of k to the fourth is just k squared. Square of 81 is just 9. So I'm gonna have my two parentheses, k squared and 9, k squared and 9. This one gets a minus sign, this one gets a plus sign, and that's your answer. Now in this case, this is not, if there's a binomial in B, it's a binomial, but 2 is not a perfect square and 50 is not a perfect square. So this is not a direct difference of perfect square. Let's see. Okay, I think that's it. Yeah, all right. Let's move on to perfect square trinomials. Okay, there are two formulas for this type of polynomials, and I'm going to do an example before I go into the formula itself. I'm going to write out the formula. The first formula is a squared plus 2ab plus b squared, and that's going to equal to a plus b times, that's a plus b squared. And the other formula now is a squared minus 2ab plus b squared, and that's just a minus b squared. Okay, you must be saying, what is this? Well, let's do some examples and see how it works out. Okay, so the first, I'm gonna look at the polynomial. Let's do this one first. X squared plus 4x plus 4. I don't think this was on your handout. I just made this one up. Now, when you're given a polynomial like this, normally your first instinct is to the X box method. Because that's what we learned last week, right? You would go to the X box method. Well, before you start thinking about X box method, I want you guys to go through these steps first to see if there's an easy way to solve this. Look at the first term. Is the first term a perfect square? Yes. This is a perfect square. What about the last term? Is that a perfect square? Yes. And so if they're both perfect square, right, I'm going to take the square root of the first term, the square root of the last term. That gives me an x, that gives me a 2. Now I'm going to write my parentheses. One gets an x, they both get x and 2. But in this case now, because it's this trinomial, this is not the binomial we did before. It's a trinomial. They both get, because this is a positive sign right here, they both get positive sign. Am I done? Well, there's one more check you must do before you can say these are the factors. One more check. I want you to multiply the inside terms, 2 times x, that is 2x. Multiply the outside terms, x times 2, this is 2x. You add these together, add, you get 4x. If that matches, then yes, x plus 2 times x plus 2 are the factors. And you can simplify this one step further by writing it as x plus 2 squared. All right? Remember, it's just like x times x. It's just x squared, right? You have 2 same terms multiplied by each other. So you can put as one as x squared. So x plus 2 squared. All right. Let's try another example where in this case it's minus sign. Okay, let's do this one now. Let's see. We have x. Let's go with minus 6x plus 9. Okay, so you're going to ask yourself now, x squared. Is this a trinomial? Yes, it's trinomial. It's 3 terms. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. So I'm going to take the square root of x squared and the square root of 9. That gives me an x. This gives me a 9. I'm going to write my parentheses now. I'm going to have x and 9, x and 9. But now, because this is a minus sign, they're both going to have a minus sign. Now, let's do our check. I'm sorry, this should be 3. Square root of 9 is 3. Oops. Sorry about that, guys. Okay. So let's do our checks now. All right. Got to make sure that this is correct. 3 times x is negative 3x. X times negative 3 is negative 3x. When I add, right, these two, I get negative 6x. Yes, so therefore, this is a perfect square trinomial. And so I can write my answer now as x minus 3 squared. Now, I must be asking, why are we doing these checks? Why? Well, I'm going to show you another example why it's important. All right. Let me erase this and do one on this side over here now. Draw a line. Let's do this one. X squared plus 5x plus 4. Okay, let's go through our checks. It is a trinomial. Yes, 3 terms. The first term is a perfect square. The last term is a perfect square. Yes. So I'm going to take the square root of the first term, which is x, square root of the last term, which is 2. So I'm going to have my parentheses now. X plus 2 and x plus 2 is plus because it's this plus sign right here. Well, let's go to my checks now. I want to make sure that these are the real factors, absolute factors. All right, so I got to do my checks now. 2 times x is 2x. X times 2 is 2x. When I add these 2 x's now, 2x plus 2x is 4x. Well, guess what? That's a 5x. So therefore, because the check failed, x plus 2 is not the factor. of this polynomial. This is not a perfect square trinomial. So how do we factor it then? We just have to use the X box method to factor it. All right. So this is where the checks fail. When it fails, then you know, then x plus 2 and x plus 2 are not the factors of that trinomial. Therefore, this is not a perfect square trinomial. Right. So that's why it's very important to do your checks. All right. And we'll do one more. Let's go back and look at the handout now. Let's see what we missed on the handouts. Let's see. Determine the trinomial if there are perfect square trinomial. Let's see. Let's look at the first one. All right. We have 9x squared. We have 9x squared. That's 9x squared minus 26x plus 25. Okay, so this is a perfect square. Yes. That gives me 9x. I'm sorry, 3x. This is a perfect square. That gives me 5. So now I'm going to have 3x minus 5, 3x minus 5. Remember, this is a minus sign right here. Let's do our checks now to see this is actually a perfect square. Negative 5 times 3. I multiply the inside terms. That's negative 15x. And if I do the outside terms, right, the outside one now, 3x and negative 5 is negative 15x. When I add these two, it gives me what? Negative 30. No, it doesn't match. So this is not. Okay, let's try the second one. X squared plus 8x plus 16. Okay. This is a perfect square. X squared is, that gives me an x. 16 is a perfect square. It gives me a 4. So now I'm going to have x plus 4. Again, I'm going to have x and 4 on both sides, right? Remember that. But because it's a plus sign right here, there's going to be a plus and a plus. Let's do my checks now. I'm going to multiply the inside terms and the outside terms. The inside terms, 4 times x, that's 4x. The outside term, that is 4x. When I add them, I get 8x. Yes, that is a perfect square trinomial. And those two are the factors. So my answer now is going to be x plus 4 squared. All right. And I'm running out of time right now, guys. I got to go to my next class. So here, you check to make sure the first and last term are perfect square. All right. Then you take the square root. Take the square root of the first term to find the a. Take the square root of the last term to find b. And that's what we did, right? And then we plug it in. This is my a, that's my b, that's my a, that's my b. And then if it's a plus sign, I put the plus sign right there. And then my check is, I just multiply 4 times x, the inside term, x times 4, the outside term. Okay. And let's see. Let's see if I can do one more. Let's look at a real quick. So a, we have x squared minus 10x. We have x squared minus 10x plus 25. Okay, the first term is a perfect square. That gives me an x. Last term is a perfect square. That gives me a 5. So I'm going to have x and 5, x and 5. Now, this is a minus sign, so I'm going to have a minus sign here. Let's do my check now. The inside term, negative 5 times x is negative 5x. Outside terms, x times negative 5 is a negative 5x. And when I add them, that gives me negative 10x. So yes. All right. All right. Let's do one more. Let's try C. Let's try C. And then I have to stop here. Okay. The first term, this is a perfect square. That's a perfect square. So let's take the square root of that. That gives me 4x. Let's say the square root of that. That gives me y. So I'm going to have two parentheses, two sets of parentheses for x and y. I'm sorry, this will be 2x. 2x. So 2x and y. This is a plus sign, right? So a plus go here and a plus go there. Let's check to make sure I get 4xy. Y times 2x is 2xy. 2x times y is 2xy. When I add them, it gives me 4xy, which is this. So yes, that is. All right. All right. Go ahead and try B and D and see if you get the answer. All right. And that should be, you should be ready for the quiz tomorrow.